All right, welcome to the 4.4 video. Here, our goal is to simply solve logarithmic equations. Now, again, a logarithmic equation, the key word here is equation. There's going to be an equal sign, okay? So, I want to make sure that we're really logarithmic equation. I just want to make sure that we are 100% certain what it means to be a logarithmic equation. Right? It simply means there's an equation where there is a variable inside a log. Okay, so that means there's going to be a logarithm with a variable in it. So there's going to be an equation that has a variable inside of a logarithm. Okay, there's equal sign and a variable inside the logarithm. All right. Now, there are two types of log equations. All right, so we have type 1. And type 1, this is where you're going to have logs on both sides. And it's important that we make that distinction, okay? We're going to solve these completely differently. So when you see a logarithm on both sides, you're going to solve it differently than whenever you just see a logarithm on one side. So here, our type 2 is where you're going to have logs on one side. Yeah, when I say side, we're talking about the equation, right? Okay, so I'm going to just hammer it out. I'm going to write down the steps on how to solve each one, and then we're going to go through and review those steps as we practice a few examples. So for type 1, we want to make sure that the very first thing is that there's only one log on each side. And then we need to make sure that we make, as long as they have the same base, then we can, I'm going to say it like this. It's not the right terminology, right? But we're going to set the insides equal to each other. And then we're going to solve. All right, so we need to get one log on each side. As long as we have the same base, then we can set the inside part, the argument, equal to each other. And the last is we're going to solve the remaining equation. I'll show you exactly what that means here in just a moment. Okay, what if there's only one logarithm, right? So or logarithms only on one side. So the first thing I need to do is I need to make sure that I have one logarithm on one side, one log on one side, and then numbers on the other. In other words, we're going to isolate the logarithm. Step 2, we're going to convert to exponential form. Right? Remember, that's the definition of logarithms. This go back to 4.1. Right? How do we go from logarithmic to exponential, exponential to logarithmic? So we need to convert here. So this is 4.1 stuff that we talked about. And then finally, the last thing is we're just going to solve. We're going to solve the remaining equation. Okay? So each of them have just 3 steps. No big deal. So let's take a look at a few examples. All right, so the first example we're going to take a look at is we have log of negative 2a plus 9 equals log of 7 minus 4a. All right, so I need to ask myself. So here's our first example here. All right, and the directions are just simply going to say solve. So is this a type 1 or type 2 equation? Well, here's my equal sign. All right, my equal sign's here. I have a logarithm over here. Again, and I have a logarithm over here. So I have logs on both sides, telling me that this is a type 1 equation. All right, so I check the base. So one log on each side. So I have one logarithm over here, and I have one logarithm over here. So step 1 is done. Step 2, make sure they have the same base. So log base 10, log base 10. Okay, now that they have the same base, I can set the insides equal to each other. Well, here's what the inside is. So I'm going to say, well, if I have these logs, then that must mean that negative 2a plus 9 equals 7 minus 4a. And now I'm going to solve. Well, I have variables and numbers on each side. Again, I want to get all my variables on one side and my numbers to the other. So here I'm going to move all my variables to the left side and my numbers to the right. I have a negative 4a, so I'm going to add 4a to both sides. A negative 2a plus 4a is a positive 2a. Everything else stays the same. Subtract 9 from both sides. So 2a equals 7 minus 9 is negative 2. Divide by 2, and a equals negative 1. All right, so the first example, right, we had logs on both sides. So we made sure there was one log on each side. They had the same base, so we set the insides equal to each other, and then we solved. A is going to equal negative 1. All right. Now, let's try a few more examples. Let's try log base 9 of negative 11x plus 2, and that's going to equal log base 9 of x squared plus 30. All right, so what type? Is this a type 1 or type 2? This looks like a type 1 because I have a log on both sides, and I have exactly one log on each side. So now I have to check, do I have the same base? And if I do, I'm going to set the insides equal to each other. So my base on the left side is 9. My base on the right side is 9. So that part works. Now I get to set the insides equal to each other. So now I get 11x, or negative 11x plus 2 is going to be equal to x squared plus 30. Now I have an x squared. So this is going to be quadratic, right? So, hey, I have x squared, which tells me this is quadratic. In other words, I'm going to get the whole thing set equal to 0, and then I'm going to try and factor. And I want my x squared to be positive. Since x squared is positive on the right side, I'm going to move everybody to the right. So let's add 11x plus 11x. So I have 2 equals x squared plus 11x plus 30. And now I have to subtract 2 from both sides, minus 2, minus 2. So this gives me 0 equals x squared plus 11x plus 28. Now I have to try and factor if I can. So I want to factor. Factors of 28, we have 1, 28, 2, 14, 3, no, 4, and 7, 5, no, 6, no. So I want to start with the ones that are closest together. And I get x and x, 4 and 7. This second sign tells me they're both going to be the same sign, and they're both going to be positive, so plus and plus. When I go to check, I have a 4x and a 7x. 4x plus 7x is 11x. All right, so I know these are my factors. So I set each factor equal to 0. X plus 4 equals 0. X plus 7 equals 0. And solve. X is going to equal negative 4, or x equals negative 7. All right, not too terrible. Now, let's try another one here. This one's going to make things a little bit more interesting. Let's go log base 9 of x plus 6 minus log base 9 of x, and that's going to equal log base 9 of 2. All right, so I have logs on both sides. Now, this is going to be a type 1 equation where I have logs on both sides. I need to make sure that I have only one log on each side. So over here I have 2 logs, and over here I have 1 log. So what do? How can I make these 2 logarithms into 1 logarithm? Well, this is the minus sign here, right? We talk about condensing back in 4.3. We're going to condense these logarithms. Excuse me, I believe that was 4.2. We're going to condense these. So the log of the first one minus log of the second one, and I'm going to take my arguments, and they're going to be divided. So here I'm going to end up with log base 9 of x plus 6 over x, and that equals log base 9 of 2. Now that I have 1 log on each side, right, so let's go check our steps again. All right, 1 log on each side, check. Same base, log base 9, check. Now I'm going to set the insides equal to each other. So the inside here is going to be equal to this. So I end up with x plus 6 over x equals 2. And now I need to solve this. Well, one thing I know is that I don't like the fraction, right? So how do I get rid of the fraction? Well, I'm going to get rid of it. So this is really division, and the opposite of division is multiplication. So here I multiply both sides by x. These cancel, and I get x plus 6 equals 2x. And now what's really awesome, I want to get variables on one side, numbers on the other. Well, I only have a 6 over here, so if I move the x to the other side, so this subtract 1x from both sides, that's gone. I'm left with 6 equals 2x minus 1x is just x. And that's my answer. All right, I'm going to look at type 2 equations on the next video.